All right, so going over some practice problems from the textbook. So this is question 3 that we're doing right here. This is question 3. So we have a triangle. We have a triangle in question 3. It's a right angle triangle. This is our right angle triangle. There's the square saying it's a right angle. This side here is 8.6 centimeters. This side here we'll say is 5.8 centimeters, and up here is 10.4 centimeters. Okay, and here is our angle theta. Okay, here is our angle. The textbook has sort of drew the line. Okay, but we'll use the angle theta. Now, given that this is our angle theta, we're going to define our sine, cosine, and tangent ratios. So sine, actually the first thing I'm going to do is write my SOHCAHTOA to have that clearly on my page. SOHCAHTOA. Okay. And then I'm going to define my sine, cosine, and tangent ratios. So sine theta will equal what? Cos theta will equal what? And tan theta will equal what? So take a second and try to fill these in. Let's explain it. So the first thing I would do when approaching this is just define, make sure I have clearly in my mind which side is opposite and which side is adjacent. So this is my angle right here. This is my angle theta. So the side opposite this angle is going to be right here. This is my opposite angle. And the side adjacent is the closest side that's not the hypotenuse. This here is the hypotenuse. So here is my adjacent. Okay? This is my adjacent. And this was my opposite. And of course, this side here, opposite the 90 degrees, the longest side, is my hypotenuse. So for sine of theta is going to be opposite over hypotenuse. Here's my angle. Opposite is 5.8. So this is going to be 5.8 over my hypotenuse, which is 10.4. Cos of theta is going to be adjacent over hypotenuse. So here's my adjacent is 8.6 divided by the hypotenuse, 10.4. And the tan of theta is going to be opposite over adjacent, TOA. Opposite here is 5.8. And adjacent is 8.6. Okay, that's it for number 3. So we'll go on and give number 4 a try. So here's number 4. And these things, like, you just need to do 3 or 4 of these to practice, and then it becomes second nature. So here's another triangle. So actually, let me pause it here and just ask anyone if they have any questions. So all we were trying to figure out in this first one is what do these ratios look like, okay? So this is all we're trying to figure out. We're defining sine theta. Sine theta equals 5.8 over 10.4, okay? We haven't even come to try to solve what the angle actually is, okay? We're going to be doing that next. Right now, we're just defining, do we know what side is adjacent? Do we know what side is opposite? And can we write that as a trigonometric function? Can we write this? Do we know how to write tan theta equals 5.8 over 8.6? That's all we're doing, okay? In the next few lessons, tomorrow and the day after, we'll actually start calculating the angle, okay? Right now, we're just writing these expressions correctly. That's all we're doing, okay? So for question 4, we have another angle, and the angle's up here, okay? So the angle's in the same spot. We have 12 meters on this side. We have 5 meters down here. And we have 13 meters over here. Okay? Here is our 90-degree angle. Now I want you to take a second and write out the expressions for sine theta. What will sine theta equal? What will cos theta equal? And what will tan theta equal? So the ratio of sine theta, the sine of this angle here, will equal what ratio of the sides of the triangle? So take a second, identify your opposite, your adjacent, and write out the ratios that each one of these trigonometric functions will equal. So sine theta is going to be opposite over hypotenuse. Here's our opposite right here. This is our opposite. And we know what our hypotenuse is. So sine theta is going to equal 5 over 12. Or sorry, 5 over 13. 5 over 13 right there. Okay. Cos theta, cos is adjacent over hypotenuse. The adjacent side is right here. Okay, this is our adjacent. So cos theta equals 12 over 13. 12 over 13. So tan theta is opposite over adjacent, our TOA, opposite over adjacent. So here's our theta, here's our opposite, and here's our adjacent. This is the adjacent. So 5 over 12, tan theta equals 5 over 12. All right, let's do one more. This will be on a fresh page, but we can jump back and forth. This is number 5 in the textbook. So here we have a triangle. Oops, actually, make it black. Here we have a triangle. Here is our triangle. And so here's our angle here. Here's our angle right here. This side is 38 centimeters. This side is 29 centimeters. And this side is 24 centimeters. Okay? Let's write out our sine theta, cos theta, and tan theta ratios. Okay, first thing I would do is on the top of my page, write out my TOA. Okay, now take a second and try to figure out what those ratios are. All right, so sine theta, what does sine theta equal? So here's my angle. This side over here is my opposite. This is the opposite side to this angle. This side here is adjacent. Adjacent means beside. This side here is beside the angle. This side here is the hypotenuse. This side here is the hypotenuse. And yes, the hypotenuse is also beside the angle, but the hypotenuse is special. It has its own name, hypotenuse. The other side is our adjacent side. The side across from it is our opposite side. Sine is the ratio of the opposite side divided by the hypotenuse. So our sine function is going to be 24 over 38. Our cos function is going to be our adjacent 29 divided by the hypotenuse, 38. And our tan is going to be opposite over adjacent, which equals the adjacent is going to be 24 over 29. Well done. Let's do one more. This is going to be question 6. from the textbook. So here we have another right angle triangle. Here it is, right here. This is our right angle, okay? This is our theta is down here. Our theta is down below over here, okay? This side is 12 meters. This side is also 12 meters. And this side is 17 meters. Okay? What is our sine theta, cos theta, and tan theta going to equal? All right, let's fill this in. Sine theta equals what? What does sine theta equal? So sine theta will equal our opposite. Here's our opposite. Okay, this is the opposite over the hypotenuse. Our hypotenuse is 17. So sine theta will equal 12 over 17. What will cos theta equal? Cos theta will also equal 12 over 17. There's our adjacent side. This is our adjacent. 12 over 17. And what will tan theta equal? Tan theta will equal our opposite over adjacent. 12 over 12. Okay. So some questions from the textbook to work on right now. Yeah, page 60. We went over questions 3, 4, 5, and 6. But you can try those, a couple of those on your own and compare them. So we have questions 3 to 6, which we did together, which you can still try. And then to challenge yourself, going a little bit further, you can try questions 8, A and B. And question 9 just asks you to make your own example and to try it out. So give question 9 a go.